Okay, now we heard in the first session about great advances in medicine. Now, I think it's time for advance in climate science. And the idea that scientific evidence is consensus, i.e. consensus is scientific evidence, is absurd. I mean, you know, this is what the Pope said to Galileo. Look, we know, go to hell. Well, in fact, he was shown the instruments of torture. And the Spanish Inquisition was no help either. And I've noticed in the first presentations, there is great advances going on, but application is far behind. And that covers almost all scientific advance. And you people, many of whom I believe are young, but I can't see through the dark, you know, it's a question of world organisation, which means good ideas are going to be implemented or not, which is where you're going to come in. Now, can we look at slide number 1? Oh, I pressed, don't I? Okay. There we are. So, what's it all about? It's the economy. And I'll have to skate over these because I've got a lot of things to cover. Various weather events will change energy prices, which is of great importance to the economy. And I would point out that climate change policy as well causes economic, you might think, answers, but no, problems. A lot of the problems of Spain now are to do with delusional investment in silly green projects which were doomed to fail. Now, I realise I've upset quite a bit of the audience here, but just, you know, bear with me for the time being, and we'll come to as many questions as you like later on. Okay. Now, this is the key messages I've got to say. And this will definitely upset some of you. CO2 theory of climate change has failed. It's failed science and must be rejected. I'm here bringing you a new paradigm of climate and weather science. Namely, it's solar magnetic lunar effects which are predictable, which can predict weather extremes months and years ahead, and also climate change. And the challenge is to apply this knowledge. Now, as I said, consensus never advanced anything. If you think about it, no scientific advance equaled consensus. No, not at all. Scientific breakthroughs are breaking through consensus. So to rely on consensus as justification, as the first speaker just now did, is, I have to say, silly. Okay. Now, we are going to show, or I can show, that our theory indicates that world temperatures will continue to decline till 2035, and we're heading for a little ice age. And what we need to address is a change in policy of attitude towards climate, i.e. put predictability to the fore. Now, so I'm going to do the first part of my talk dealing with what's wrong with, or what doesn't work in climate and weather, and then what does. So I'm going to be as quick as possible on what doesn't work. First of all, the IPCC predictions for the last 10 years were CO2 would go up. It did. And as a consequence, they said temperatures would go down, which they said temperatures would go up as well. And they put that purple band, the pinkish band, as the range of possibilities. And as you know, world temperatures have gone outside that band of possibility. Next thing they said is things like there'll be a great number of more storms. Well, there's been no increase in storms. There has been more very severe events in the last year or so, most of which we predicted using the sun. Next one, there we are. I'll go to the next one. Right. Sea level rise. First of all, you've got to understand that sea level has always been rising since the last ice age. The bottom of the ocean is still warming up. The question is, has the rate of rise changed due to more CO2? And there's the graph, and it shows you the answer is no. Now, Al Gore, he said, look at the graphs. CO2 and world temperatures move together. And his advisors indeed advised him this. Or perhaps he asked his advisors to advise him this, I don't know. But anyway, there we have it. They move together, yes. But when you look at the details, you see what's actually happening. world temperatures, i.e. the ocean temperatures, drive CO2 changes, i.e. CO2 rises follow increases in world temperatures, because a warmer ocean won't absorb so much CO2. In fact, it chucks it out, takes a lot of time because of ocean circulation, and so forth. And the next graph shows that. Now, time is going the opposite direction on this one, and you can see, I don't have one of those magic pointers, actually. But of course, I can't point at, no, I couldn't do it anyway. Okay, anyway, you understand, you can see the top graph is average temperatures going from right to left, and the next one down is CO2. So there's a lag. CO2 levels, after, it's a slow process, but they're driven by temperatures. Now, what about long-term history? Billions, hundreds of millions of years. Is there any relationship between CO2 and temperatures? The answer is no. Here's the graph, and this is a generally accepted graph. I think these guys here will agree. And they say, well, it was warmer in, 3 or 4 million years ago, which is still in the green section there. Because again, time goes backwards on this one. It goes forwards. The green section is the most recent, okay? And the 3 or 4 million years ago is about the middle of that green, or in the hump. Now, the top part of that graph is average global temperatures. So it's much warmer then, okay? And you look in the past, there was various fluctuations, but in some of them, a lot of them, CO2 goes up when temperatures go down, and so on, okay? No relationship. But you might ask, well, why was it so warm 3 or 4 million years ago? Well, I'll tell you why it was so warm. There was twice as much atmosphere. Now, the atmosphere is full of stuff. It's not just CO2, water vapor, smoke particles, aerosols. All of them mean that it's the upper atmosphere which counts for interchange with space. Now, if there's twice as much atmosphere, you can work it out. The thickness of the atmosphere, twice as much weight in the atmosphere, goes up by a third. That means that the effective distance a molecule has to fall from the top to the bottom, which is something equivalent to its warming, will increase by a third. So the warming would, instead of being 33 degrees, is going to be 10 degrees more. Look at the picture, it's gone. There you are. The temperatures then were about 10 degrees more. I mean, this is a big simplified theory, I know, but that is the key reason why there's been a lot of fluctuations in the past. Amount of atmosphere, nothing to do with CO2. Now, how do we know why it's not CO2? Well, I'll just repeat that it's not because of all the meddling and fiddling of data, which was a scandal, that's true. It's because the theories do not match the facts. Climate change is a natural process, and in fact, CO2 is a good thing, not a bad thing. It's plant food, after all. More CO2, plants grow faster. Now, if a theory isn't matched by the facts, the answer to science is change the theory. Okay? That is normal. Do you agree with that? Speak. Say something. Do people agree with that? Yeah, someone said no, they don't. Okay, good. The normal thing is, if a theory doesn't match the facts, you have to change the theory or discard the theory. However, some people, the University of East Anglia, and there was involvement by the IPCC, decided to change the facts. Now, fortunately, some media got hold of them and exposed it. But we are not there yet. Now, you might say, well, why? If this is all, if it's such nonsense, why is it still holding sway? Well, the answer is the same as the problem faced by Galileo or Harrison when he was measuring longitude and so on, is there are interest groups and you have to just follow the money. And one of the biggest interest groups, despite public claims, the biggest interest groups backing this, what I will call CO2 delusionism, is the oil companies. They love price rises. They don't want to go them completely through the roof, no, but just, 30%, 40%, 50% price rises. They like them because it increases the value of all their assets underground, their shale oil and so forth. They've got stuff worth trillions, which before was worth nothing. So, and they do not like me. And there have been failed theories before. The CO2 one is just one of them. I've got a little list on the bottom there which has disappeared, but it doesn't matter. We could, Lysenkoism and so forth. Now, what I want to do, and I don't know how much time I've got left, is talk a bit about what does work. Okay, now here's a list of extreme events. The West Russian heat wave last summer, the coldest temperatures in Western Europe and the United Kingdom for 100 years last December, a very cold winter in America, the Queensland tropical cyclone Yasi and the associated floods, a series of American tornadoes, such as the one which destroyed Joplin, Missouri, a series of major earthquake and volcano periods, and, for example, Hurricane Irene, its detailed formation and track. All of those events were predicted by the solar-lunar action technique. Now, doubtless the global warmers will say they're all to do with CO2. Look, that is nonsense. Anything that happened, they would say, is to do with CO2. It's religion, what they're putting forward. Now, you can have religion, I don't mind, but don't impose on me what you think. Okay. But what actually does cause all this stuff? How do we get to know about it? I've got to speed up. The basic thing is shifts in the jet stream. Okay. We can predict changes in the jet stream, which is the track of low pressure systems around the world. And here's an example of a jet stream, and you could click on it and find out how it moves. But it's what happened on August the 15th, and it suddenly moved towards St. Petersburg, Russia, and that was heralded the end of their hot spell, and we predicted that date. Here's a graph showing historical, over many thousands of years, relationship between particles from the sun and world temperatures. There's a close relationship. Okay? Now, does anyone here remember Fourier analysis? You could put up your hand in the dark if you do. I see somebody, but they might be just waving. Okay. Anyway, this shows you what is the main fluctuations in data. Okay. Now, the top graph shows you the most important variation in geomagnetic activity, which is about particles from the sun, is the 11-year, or thereabouts, solar signal, solar activity. The most important variation in world temperatures is shown by the bottom graph, the peak, biggest peak in the bottom graph, which is about 22 years, which is the magnetic cycle of the sun, because the sun changes its magnetic field every 11 years. Okay? That is the main signature in world temperatures. The reason being it's the charged particles connecting with the Earth through the magnetic fields, which are causing shifts in the jet stream and so forth. And when you bring the moon into this, you can see, and here's a graph of America, because if it doesn't happen in America, it doesn't happen anywhere, there is a 60-year modulation of this. Okay? Now, you can understand 60 years. It's in fact to do with the beats between the rotation of the plane of the moon's orbit and its interruption with the solar wind. So it goes one circle in 18 years, so it's 3 years behind each time. And after 3 of those cycles, it's going to be 9 years behind, which is half of one of these nodal crossing periods, which the lunar nodes are going for or against the sun. So we won't go into the details, but you can work out the beat period. It's about 60 years. And there we have it. And there we have the same beat period in the Tibetan plateau. So those people that go to Tibet and say it's all man-made, that's nonsense. It's here, a graph showing you it goes in 60-year cycles. Here we have another one. Big events in America. Sorry, here we are. There was a lot of tornadoes, very damaging ones also about 60 years ago, but probably more significantly, there was also very big Mississippi floods 60 years ago or so, as there were now. There's a whole lot of things which cover these rough 60-year cycles. And those of you that like, theories of beats in music will understand this, that there's the formula which gives us 58 years or thereabouts, okay? So it's explicable, okay? And you can see it in more detail in the world temperature data and where the moon has to be. But basically, if you've got an odd sunspot cycle peak and lunar eclipses in early December, you will be near a peak of world temperatures. Okay, in questions we can go through that. How many minutes have I got? 5. Oh dear, okay. So there we are. There's a rough formulation. What happens to the world is a product of solar activity, magnetic links, and lunar modulation. And I'll just draw your attention to, if you work things out, it means 132 years ago, there may have been similar certain seasons. And indeed, in England, we had floods in 1875, 1876, 1877 and 1879, in the Mister year. In the United Kingdom, we had floods in 2007, 2008, Mister year, and 2009, yes. Yeah, that's right. Sorry, no, we haven't missed a year. Yes, we've had those 3 years, and then we had another one as well, which was also predicted. So there is a 132-year signal. It's also the case of specific events, that there were heat waves in Russia then, and also there were those big floods in Spain, in Bangladesh, Pakistan, West Pakistan, 132 or so years ago. Here's pictures of the floods we predicted and the Met Office did not predict. And there's somebody skidding on ice that was skidded on ice because there wasn't enough salt, because they believe the Met Office forecast. Now, I've got to get you to this slide. The next one is to show you what happened on the sun just before this big change on Earth. Now, can we play that video, please? Okay. This is August the 15th, 2010. A very dramatic event on the sun, which triggered the predicted change that occurred. And he's going to press some magic buttons, and it will come. There we are. Here we are. That is a pair of sunspots. A very unusual pair of sunspots, very active, still warming up. There's meant to be music, but maybe we don't get that, doesn't matter. Sunspots 1093 and 1099, they erupted, and we're going to watch as the Solar Dynamics Observatory. There you are. See that spurt coming out of the sun? Now they do it again in colour. Look at that. Zoom. Is that it? Might be. Seems to have got stuck. Anyway, there we are. That was a bit quick, you agree. But that stuff that came out, some of it was travelling at half the speed of light. Oh, there we are. There we are, more detail. That started affecting the Earth about, 15 minutes later, in fact, but it started affecting the jet stream 12 hours later. And can we just move to the next one, because I don't have much time. There we are. I think it goes in a loop unless we stop it. Can I just move to the next slide? No. Yes? No. Okay. Well, that's a burst of energy from the sun, hit the Earth, shifted the jet stream, and there we are. Now that's very good. There we are. Oh. Well, okay, you'll have to... It's the other picture before. It shifted the jet stream, caused the St. Petersburg thunderstorms, and the ending of the floods in Pakistan, because the whole jet stream pattern changed, okay? Now, we better skim through a few things quickly before I'm going to give you some extreme weather event forecasts around the world. This is the very cold winter. Not moving. Is that meant to pick up? It's not moving forward. Hello? Next slide, please. Oh, yeah. Oh, too fast. Okay. Anyway, I'll do these quickly. There we are. Very cold winter, December, Britain. Blizzards, and then a big tropical storm, Yazzie, hitting Queensland. Then the same thing happened again 14 days later. Again, we predicted it. And here we have your favourite royal couple. driving through beautiful weather, which we predicted, and the Met Office said it was going to rain. And that was, we said that 28 days ahead, and they were still wrong 2 days ahead. We'll cut out this detail. There's little discussion there about predictability of earthquakes. We predicted an earthquake and not a volcano, which is maybe a consolation prize, but we understand the connection. These are trial forecasts for earthquakes and volcanoes, I hasten to add, but very interesting. Here's Hurricane Irene as predicted. The US government so far has shown no interest in those things, though. Now, I've got to end on two things. One is what's going to happen in the next 25 years. And you can see here, looking at the one at the top graph is a solar activity graph and a projection. The bottom one is world temperatures. And you see there's a bottom bit, which is around 2035. We are predicting world cooling to carry on till then. It's going to be an ice age as well, but that is not next week or next month, or it's like 1,000 years' time. We can show detailed arguments what's wrong, and I just want to now give some forecasts for the next few months or so. You write these down, but they'll be recorded, obviously. First of all, the United Kingdom and Western Europe, and including Spain, are going to see an exceptionally cold period, a long period, much, much colder than normal. Could even be as cold as last year, between around the 27th of November and the 28th of December. Okay? Very, very cold. And there'll be huge snowfalls around the 2nd and 14th of December in a number of places, which we will predict in detail later. Around the same time, or a bit before that, or part of that, the USA in the middle will be exceptionally mild around the 15th to 17th of December. And then the 31st of December into January, Canada and North USA will have exceptional, very exceptional cold. And there'll be massive snow in northeast USA, 11th to 14th of January. And on the 17th to 19th, there will be a very interesting, very extreme, huge storm on the northwest coast, which will cause damage. And lastly, if you want to get away from it all, go to Australia between about the 18th of January for 2 weeks. It's going to be a very extreme heat wave. Of those 6 forecasts, we expect at least 5 of them to be correct. And now I'm going to end the end and say what you ought to do. One is enjoy life. Stop feeling guilty about driving a car. Just drive it, okay? And you're adding CO2 and plants like it. And, attack the carbon con. Don't pay these surcharges. And do honest green things, yes. Defend rainforests for biodiversity. Do good things for good reasons. Do not accept the con, which is creating a bubble of false value which will blow up. And I would urge you, what we really need is the UN to adopt these predictions that I have. That will save money, save lives, reduce disruption. And you have to fight for accountable science, evidence-based science, and accountable science and politicians and policies. Thank you.